So the next topic would be diffusion surface hardening treatments. So diffusion surface hardening treatments, that mean that the name itself it contains the meaning of the surface hardening can be taken place with the help of a diffusion methodology. So hardness of the surface is improved by using diffusion of industrial elements like carbon, nitrogen, and both into the surface of steel components. So carbon, if it is diffused above the steel, is called the carburising process, and nitrogen is diffused into the steel, it is called the nitriding process. So depending upon the different elements chosen, diffusion treatments can be classified into carburising, nitriding, cyaniding, and carbonitriding. First, diffusion surface hardening treatments. So first of all, hardness of the surface is improved by diffusion industrial elements like carbon, nitrogen, and both into the surfaces. So how carburizing is taking place into the materials. So carburizing is a hardening process in which the carbon is introduced into the surface layer of the steel. That means in a particular area of a material to be improved their hardness means then in that particular area itself it covers with the help of a carbon. So this process is nothing but case hardening methodology of carburizing. So how it is going to be done means the steel is heated into a contact with the substance that has a high carbon content. Steel is held at a temperature above the upper critical point like 850 to 950 degrees centigrade for a stable period of time. Then continue rapidly to produce hardened surface layer or case over a softer or tougher core. The steel is then tempered to the desired hardness. So after completing this carburizing process, the tempering is also to be done to improve its hardness. So carburizing is done on low carbon steel. It is less than 0.25 percentage, and the carburizing time varies between 4 to 70 hours. The length of the time of the steel is left in the furnace determines the depth of the carburizing. Case depths are ranging from 0.08 mm to 6.4 mm, may be specified depending on the surface requirements of the product. The carburizing process does not harden the steel, it only increases the carbon content to desired depth below the surfaces. So that means if we want to increase the hardness of a particular area, then we have to apply the carbon content on the surfaces by using the above procedure, then we may be able to develop their hardness. Carburizing. Carburizing process, it contains gas carburizing, pack carburizing, and liquid carburizing. There are three types of carburizing process are there. Then the next type would be nitriding. So nitriding is nothing but the another process which a case hardened steel can be achieved. In nitriding, the steel piece is heated in a furnace between 500 to 600 degrees centigrade. At the same time, it is exposed to ammonia gas. That means ammonia gas is contained of NH3. So the heat from the furnace causes the ammonia to decompose into the hydrogen and nitrogen. So this NH3 atom is split into two atoms like hydrogen and nitrogen atoms. That the nitrogen atom is reacted with this element of the steel to form nitrides in the outer layer of the steel, providing high hardness and wear resistance. So night riding time range between 1 to 100 hours depending on the steel composition and depth of the hardening desired. So this is the simple example and simple layout diagram for night riding process. So here we have a furnace. Inside the furnace we have an element so which is going to be case hardened. So this case hardened element to be heated up to the upper critical point. Then the ammonia gas is going to be insert in inlet to this system. So on the time what happens based on this temperature, this ammonia gas is going to be exposed on this material. So at the time this NH3 is split into there are two components like nitrogen and hydrogen. So the nitrogen material, that means the nitrogen gas is going to be splitted over this case hardened material. That means this material over it may forms a layer over the material. So that can be the process can be nitriding. Then the last methodology is carbonitriding. This process involves both diffusion of carbon and nitrogen into the steel surface. However, diffusion of carbon and nitrogen, we already know that carbon diffusion can be takes place in carburizing process and nitrogen diffusion is can be takes place in nitriding process. But in carbonitriding, both carbon and nitrogen can be diffused in the steel surface to incorporate both elements to achieve the better hardness. So nitriding is performed in a gas atmospheric pressure and atmospheric temperature furnace using a carburizing gas such as propane or methane, surface of carburizing. So mixed with the several volume percentage of ammonia NH3 for sources of nitrogen. So here we may be able to identify that the propane and methane is mixed with the several volume of ammonia and it is to be exposed in the material. So carbonitriding is performed under the temperature above 700 to 800 degrees centigrade and the quenching is done with the help of a gas which is not as severe as water quench. The result is less distortion and the material is to be treated. So carbonitriding process, this is the simple layout diagram for carbonitriding process. It is a preheat zone. Here the material can be transferred in the conveyor. So in the preheat zone itself, the material can be reached up to the temperature of 700 to 800 degrees centigrade. And this is the carburizing gas and ammonia gas. Both can be enter into this furnace system. So on this area, the carburizing process, carburizing and nitriding diffusion process can be taken place above the material. After this process, the material is getting into the quenching zone. This quenching zone, the natural gas, that means the neutral gas or atmospheric air can be passed over this element. So on that time this can be getting into the room, this can be getting into the slightly quenching process can be taken place. Then it can be fell down into the water. In the water itself it can be coming back to the room temperature. Then the material is to be transferred to the storage place. Then here we may identify that the carbonitriding process, the surface material roughness can be improved of the entire component. So this is the best example for carbohydrating process. So in this video that we have covered carburizing, nitriding and carbonhydrating. There are three processes which is to be most important parameters in material science engineering because all the materials that doesn't having enough hardness. So on the case, if we want to increase a particular area to improve their hardness, then we can use this methodology to improve the hardness of that material. Thank you.